Welcome. Our first problem today is a box contains 8 red balls and 5 white balls. 3 balls are taken at random. The probability that balls are of both colors. Options: 40 by 130, 70 by 143, 3 by 13, and 10 by 13. That problem was given in West Bengal Joint Entrance Examination in the year 2012. So the problem is very simple. A box contains 13 balls. Of them, 8 are red and 5 are white. From them, 3 balls are collected at random. What is the probability that the collected 3 balls are of different colors? Means not all red, not all white, and so on. So let A is the event that the balls drawn are of both color. It means that event A, it may be of that type: 2 red and 1 white, or 1 red and 2 white. These are the possible cases. In all other cases, it will not be both color balls will appear. The probability of A, it will be equal to m by n. N is equal to, what is that? Now out of 8 plus 5, that is 13 balls, 3 are taken at random. So 13C3. And M, the favorable cases. What is that? Now we have to take 2 red and 1 white, or 1 red and 2 white. This can be done. In the first case, this can be done. Out of 8, we have to collect 2 red balls. At the same time, means multiplied by 1 white. From 5 white balls, 5C1. And second one is, it is 1 red out of 8, 8C1 into 2 white, 5C2. This is equal to 8C2, means 8 into 7 by 2 multiplied by 5. And this is equal to 8 multiplied by 5 into 4 by 2. So that sum, it is equal to M is either this or that. So this plus that, it is equal to, this one is 4, 27. So 20 into 7 plus, this is 4, 20 into 4. So that 220 divided by that. So 220 divided by that, it is equal to 220 by 13 factorial 13 divided by factorial 3 into factorial 10. This minus that. So that it is equal to, and from this, factorial 10 can be cancelled, leaving 11. This is simply 6, so it is 2. They together is 22. So after cancelling this is 10. So that answer is 10 divided by 13. So this is our answer. So this is correct option. Now the next problem. The next problem is 4 boys and 2 girls sit in a row at random. The probability that the girls sit side by side is option half, 1/4, 1/3, and 1/6. And that problem was given in West Bengal Joint Entrance Examination in the year 2011. This is also very straightforward because actually there are 6 candidates. Of them, 4 are boys and 2 are girls, and they take their seat at random on a line, on a row, to find the probability that the girls are side by side. Suppose the two girls, say they are X and Y. Take them as a single unit. Then the total number of candidates are 4 plus 1, 5. Altogether 5. And altogether 5. And our case, probable case is that they will sit in such a way that X and Y will not be separated. So they can be arranged as factorial 5 into factorial 2. Why factorial 2? Now actually X and Y are taken together as a single entity. It may so happen that first X then Y, they are not separated. Similarly, first Y then X, if they are arranged like that, they are not also separated. So this is the possible, this is our favorable cases. So probability of that event A is equal to m by n. M is equal to this factorial 5 into 2 divided by n. N is, there are 6 candidates and they are taking their seats in a row. They can be arranged as factorial 6, so that factorial 5 can be cancelled, 2 by factorial 2 by 6 only, that is 1/3 is answer. So this is our correct option. Now we discuss our third problem today, and that problem is 2 dice are tossed once. 2 dice are taken together and tossed by rolled once. The probability of getting even face in the first dice and or a total of 8, that is sum of the faces of both the dice are 8. What is its probability? Options are 1/36, 5/9, 5/12, and 13/36. and that problem was given in the year WBJE in the year 13. So two dice are thrown together at a time, and our favorable case is to get an even face in the first die. Just 1 minute. To get an even face at the first die, or a total of 8. আচ্ছা, তাহলে A is the required, A is the event that first die will get an even face, or the total of the faces would be 8. Suppose A is the even face and B is the sum. B is the event that sum of the faces is 8. So suppose this is A and B is sum of the faces is 8. It is even face. So we have to find the probability of A plus B or A union B. It is equal to PA plus PB minus P of A mid B. PA, very simple. In the first die, the face shows even, which is nothing but 3/6, that is half, plus B. Sum of the faces is 8. How it can occur? In first face 6, second face 2, in first die 5, second die 3, first die 4, second die 4, then this is 3, this is 5, this is 2, this is 6. So probability of B, possible cases is this: 1, 2, 3, 4, 5. So 5 by 2 dice are thrown together, it is 6 square, minus probability of A meet B. Both A and B happens. A means in the first face, first die, even face will show, and sum, and this sum is equal to 8. Sum is 8 in all the cases. In this case, even. In this case, first face is even. In that case, first face is even. And sum total is 8. So this is equal to 3/36. So that half plus 2/36, it is equal to half plus 1/18. So that it is equal to 18. 9 plus 1. So that 10/18. So that it is equal to 5/9. So 5/9 is our answer, and this is correct option. Next problem for today. A and B are two independent events. Such that probability of A union B bar is equal to 0.8, and probability of A is equal to 0.3. Then to find probability of B, options are 2/7, 3/7, 1/4, and 1/7. And that problem was given in West Bengal Joint Entrance Examination in the year 2009. So here the given thing is A and B are two independent events. Number one, they are independent. Number two, probability of that is equal to 0.8 and probability of A is equal to 0.3. To find probability of B, options are these. So given that probability of A union B bar is 0.8, it is simply PA plus probability of B bar minus probability of A meet B bar is equal to PA is given as 0.3 plus probability of B bar minus, as because A and B are independent, A and B bar are also independent. So it is equal to PA into probability of B bar. So that it is 0.3 plus PB bar minus 0.3 into PB bar. So that taking PB bar common, it is equal to 1 minus 0.3 is equal to 0.8 minus 0.3, 0.5. So that PB bar into 0.7 is equal to 0.5. So probability of B bar is equal to 5 by 7. We have to find probability of B. Therefore, probability of B is equal to 1 minus probability of B bar is equal to 1 minus 5 by 7, that is 2 by 7. It is our answer. So first option is correct. Next we consider our next problem. The problem is 3 numbers are chosen at random from 1 to 20. Three numbers are chosen from there at random. The probability that the numbers chosen are consecutive. The probability that the three numbers are chosen from them, numbers chosen are consecutive. So options are 1 by 140, 3 by 190, 9 by 190 and 3 by 140. Yes. So the problem is there are 20 numbers, 20 integers starting from 1, 2, 3 up to 20. And from them, 3 are chosen at random. To find the probability that they are consecutive. Consecutive means it may be 1, 2, 3, or it may be 2, 3, 4, 3, 4, 5, and this way it is 17, 18, 19, and 18, 19, 20. In fact, there are no other pair, no other selection is possible because they will not be consecutive and within 1 to 20. They are in fact 1, 2, 3 up to, you see, up to 18. So there are 18 such selections are for our favorable cases. Then if the event is A, then its probability is m by n. M, favorable case, just now we have seen it is 18 by n, all possible ways. There are 20 integers and we have to select at random 3 at a time, which can be done by 20C3. So this is our answer. It is 18 by factorial 20 into factorial 3 into factorial 17 is equal to 18 into factorial 3 means 3 into 2 into 1. Factorial 17 will be cancelled, leaving here 20, 19 and 18. 18 cancels, so that 2 cancels from there, 10. So that it is 3 by 190 and it is our answer. So second option is correct. Okay, today is up to this, and in our next class many more problems will be solved. Thank you.